To me, the challenge of this question, it is not so much of the calculation, but it is more about the interpretation of the time reference that is described by the question. Because what we need to do is to look at the total value of Mr. B's account on the 2nd of December 2003. It seems like it is 2 years later with reference to the 1st of January 2001. But the number of months where the interest is being applied, it is actually not in December 2003, but it is all the way until only November 2003. And the reason is because interest is only given at the end of the month. So on the 2nd December 2003, interest is actually not it's actually not applied to Mr. B's account yet. That is why the number of months when interest is going to be applied to his account from the 1st of January 2001 all the way until the 2nd of December 2003, it is going to be 12 times 3, okay, since it's 3 years, but minus 1 because we are only going to look at it all the way until November of 2003, and this is equal to 35. So for 35 months, the interest is going to be applied to his account. And now what we need to do is for this 35 month plus all the way until the 2nd of December. Please take note, okay, the 1st of December 2003, he's going to put in the extra $100. Okay, so and together, and at the same time, I'm going to make use of this that I've derived from part 2. Okay, I can see that the 100, which is the amount that he put in on the first of every month, the first day of every month, and this 1.005, right? It is the percentage increase, okay, taking into account of the 0.5% interest. Okay, but now we do not know what is the interest. Okay, so I'm going to let this portion here be x. Okay, I'm going to let this x, right, be 1 plus the interest rate divided by 100. Okay, and I'm going to try to solve for x first, then subsequently solve for I. Okay, so what is the total value that is of Mr. B's account on the 2nd of December 2003? Okay, 35 months, the interest is being imposed. So with reference to this, okay, it is going to be 100 multiplied by x. Then x to the power of the number of months is 35, then minus 1 divided by x minus 1. Okay, and this x is like the common ratio of the GP that we have deduced in part 2. And during the 1st of December, he's going to put in that extra $100. So this is going to be plus 100. Okay, and according to the question, this must be equal to 5,000. We are going to try to solve for x here. I'm going to bring all over to the left hand side. Okay, then I'm going to draw one graph to solve for x. So what I'm going to have is 100x, then x to the power of 35 minus 1 divided by x minus 1, bring this over to the left hand side, minus 4900. This is equal to 0. I'm going to sketch the graph of the left hand side, finding the intersection between this graph and the y is equal to 0 and the x-axis. The x-intercept is going to give us the value of x, that the unknown here. Okay, so according to my graphing calculator, x is going to be 1.0179576, and x is this. So 1 plus the interest rate divided by 100, this is 1.0179576. Solving for I is going to be 1.80%.